Hello, my name is Veronica. I'm a student at EMS doing masters. And in this video, I'll share my understanding of the exercises that are given my homework assignment for the statistical machine learning course. So we are presented with dataset and we've been instructed to provide some analysis on it. So the first part of the exercise is to do data exploration. And in our data, we have two variables, X and Y, and we have 225 observations. The relationship between X and Y is nonlinear, and we can see that there's a variability on the spread of the data points. To determine the type of task we are going to use, given that our response variable is continuous, and we'll choose a regression, and given the relationship between X and Y is nonlinear, we'll go with polynomial regression model for this task. Then second part is to determine the theoretical framework. So the first part is to suggest the function space. The function space that we'll be using will be polynomial function space. And the function space is the set of possible candidates of models that will help us to map the input to output. The next part is to specify the loss function, and our loss function will be using the mean squared error, and this is because it's usually suitable for regression tasks. And the next part will be deriving the theoretical risk, and the theoretical risk is defined as this. Also, we'll also define the Bayes learning machine, which is the base machine that helps us minimize the risk. So this is the notation for Bayes, which is represented as the expectation of Y given X. The next one will do the empirical risk, and empirical risk, it helps us to determine the theoretical risk using the training data. We cannot determine the theoretical risk because the fact that the distribution of our population is unknown. On the third task, we'll be doing the estimation of the model and model complexity. The first part is to derive the OLS estimator. So we need to find an estimator that help us to get the empirical risk, and it will also be what we'll be using to determine which one is to determine the best machine for this task. The next part we'll be doing, we wanted to see the key features of our machine. So the key thing is about the bias and variance. So bias measures how far the average estimate is from the true function, and the variance helps us to quantify the variability of the estimate due to randomness in the data. So we also have a property of bias trade-offs. We also need to balance the bias and variances to avoid the situation of overfitting and underfitting. Also, we are given a task to determine the degree of our polynomial function. Now, given that we'll be using the polynomial degree, we need polynomial regression model. You need to determine the polynomial degree. And you'll be given the method of cross-validation at V5. At V5. We chose the V5 because it reduces the computational complexity, and it runs faster compared to V10. So from there, our preferred polynomial degree is 10. And also we will compare the cross-validation empirical risk. And from here, we can see cross-validation help us to understand at what degree of polynomial degree that the model start overfitting the data. On the fourth task, we are doing the model comparison. Here we run both complex, simple, and optimal. And then our optimal is at degree 10, simple is at degree 2, and the complex is at degree 25. And you can see the complex is overfitting the data to the extent where it's now predicts even unseen data points from this point. So this shows that the more the degree of a polynomial increases, the more the model overfits the data. And the last part is trying to compare the model performance using the statistical called out. We can see from the previous chart that the simplest model was not able to predict well, given its simplicity. And also here is the worst performing model. As we can see also the median for both complex and optimal is the same. Or lastly, on exercise 1, we do further analysis to check on the test errors, and we can see there's no difference between the three models. There's a difference between the performance of the three models, which we've seen from the previous part. Also, we did a confidence and prediction band, and you can see the confidence help us to define the bands or data points. So we can see most of the data points falls within the band. And that's it. We'll do the exercise to which we are presented with a SPEM data from library CanLab. And from here, we'll compare the performance. I think that's it.